Good morning, everyone. Thank you for coming to this presentation. And I will talk about this specific project, Rowboat. And it's a 10-year project. It's a kind of a 5 plus 5 year project. And we're just finishing the 5th year of this collaboration with the City of Amsterdam and AMS Institute, which is a collaboration there between Delft and Wageningen. So a few years ago, 6 years ago, the City of Amsterdam came to MIT and said, look, we know that companies and cities, they are investing in autonomous vehicles, and we'd like to play a major role there. So how could MIT help us? So we said, why would you deploy autonomous cars in a city such as Amsterdam, where you have more than 100 kilometers of canals, more than 1,000 bridges? Why don't, instead of developing and deploying autonomous cars, you deploy autonomous boats and say, oh, this is a good idea, let's try. And one critical point is that even though when we go to Amsterdam, we see this beautiful network of canals, this is more or less half of what the city used to have in early 20th century. They paved half of their canals to give room to car. They should never do it again. So let's try to bring back some services to the canals. So how this project starts? We say it's a start by going there in a summer day and seeing this. And then we said, oh my God. How can I put an autonomous boat in this environment, right? And the first thing that we did, we started collecting data, real data of boat traffic in Amsterdam. And this has been very helpful for what is called the global path planning. So if I want to go from any point to any other point in different times of the day, the week, what's the shortest, or not necessarily the shortest, but the most efficient path? So this has been very helpful for the early stages of the project. But also, there are some projects, such as Rowboat, that we start with a solution, but then we need to find the problem, right? And then what can we, so if we have autonomous boats, so what? How this would change the city? So we did lots of workshops with residents, students, using from paper-based workshops to virtual reality to understand if people would be comfortable using an autonomous boat. And then later, at the same time, actually, we start saying, okay, but how this boat would perceive the city. So this short animation is a little bit old, but it gives an idea of what we're trying to do at the time. So obviously, this is Amsterdam again, and how boat would perceive this environment. So we start by combining different technologies. The first one, using a very low resolution imagery. It's Google Canal View in Amsterdam. And then we could detect objects. But we did not know where the objects were in terms of distance. So we start combining this image with LiDAR to try to have both technologies working simultaneously. And it was very successful at the beginning, but then later we started only trying to classify LiDAR images themselves. What's interesting for us here is that from the navigation viewpoint, Rowboat is using this image to identify obstacles and the distance. However, for the city of Amsterdam, it's much more important than that, which is the following. As we can see here, this is a drone flying over Amsterdam, and very soon you're going to see that the city of Amsterdam has a laser scanning for the entire city. However, the city has all the scan for what happens above street level, but it does not have anything from what happened between the street level and the water level. One of the reasons, obviously, is that the laser reflects in the water, and then you cannot measure much what's happening now, the depth. So Rowboat is helping the city with two things. On the one hand, by navigating there, while Rowboat is using LiDAR to navigate the city, it's also mapping the height of the canals. But also, some of you might know the city of Amsterdam is investing billions of dollars to rebuild part of their canal walls. They are very beautiful infrastructure, but some of them, they are more than 500 years old, and they are collapsing. They were not designed to receive trucks, for instance. So if we can use some technologies to also detect cracks that we can see on bridges or on canals, it can be used as kind of an early warning system to the city. Okay, look, we've been noticing some cracks. You can go there and try to fix, rather than doing the survey in the 100 kilometers of canals. While we were doing this type of experiments, we were also testing the boat here at MIT. So we start with an even smaller boat. This is a 1 meter by 50 centimeter boat. And here you can see the boats at MIT in a swimming pool. And what you see here, a few features of this boat that you can see in this image are at least three. One of them is that the boat, even though it's called a boat, it looks more like a child bathtub, right? And it's a rectangular shape. Why? Because the boats, they can latch together either along this side, but also if you flip the boats, you can have the other two boats here. One of the ideas is that rowboat is not only a boat. We call it a floating platform for two reasons. The first one is that legally in Amsterdam, a boat implies that whatever it is, this object has a captain on board all the time. So, and per definition, an autonomous boat should not have a captain, right? So we cannot call it a boat. It's called a floating platform. But also because Amsterdam, even though it has 800,000 inhabitants, in some days, like the King's Day, it receives more than 3 million people. So we could create these kind of temporary platforms on the water using rowboat. So that's why the shape is like that, so we can combine easily. Also, these boats, they are latched together. And I will show you later the development of this latching. So we start using magnets, then different forms of latching. But the latching part is critical of the project. And finally, you see that the boat has 4 thrusters. 2 here on the 2 sides, and these other 2 here. And why? Because the boat, depending on where you are with the boat, some of the canals, they are very narrow, and some of them, when we want to do this configuration, it's more efficient than, rather than the boat start navigating as a regular boat, the boat also moves laterally. So that's why we have also this configuration. And still testing at MIT, we could do the obstacle avoidance, path following, not only for static objects. Oops. Oh, where am I now? Let's see if I can go back. Okay, so not only these static objects I was saying, but also with dynamic objects. So very soon you're going to see that the boat find its way, also when we have these moving objects. And in this case, this is the postdoc fellow who developed the algorithm. And I told them wait, if you trust it, you go there. and he is still here at MIT, so he's alive, so everything worked perfectly. After several years of development, and I believe that for Amsterdam, who was investing in the project, every time they used to come to MIT, they say, oh, let's show you the boat. And then we used to bring them to the swimming pool. And I believe that for those who are investing in this process, oh my God, can I see a real boat? I'm tired of seeing these toy boats navigating in Amsterdam, right? So finally, in spite of COVID, we were able to build the boat. And we have currently 2 boats I will show you very soon. But one thing that's quite important here is a kind of a cupcake logic. You're going to see the two boats, this and the other one, but here the platform is exactly the same, regardless what you put on top of the boat. So if I want to create those floating stages, I only have this platform here, I have this stage. In this case, what we have is a garbage collector. And do you remember that I mentioned all the workshops that we did with citizens, public officials, etc.? And the trash collection was a very important use case for the city of Amsterdam. And why? Because in most of the city, trash collection is done using underground bins. So people need to walk on average 100 meters to bring their trash to the nearest underground bin. And the trash is collected every 2 weeks. It's every two days per week. But they cannot install the underground bins in the city center of Amsterdam. For a combination of factors, some of the streets are very narrow, some sidewalks are historically protected, and the canal walls, they have wooden structures. So if you dig there, you damage everything. And we thought, okay, why keep the canals only as a tourist attraction? Why not bring back to the canals trash collection? So this is what we're doing. So if the city were to dig I will try again. Okay. I think there's a timer, perhaps. If the city would dig the underground bins, it would need to install 180 of them. And with rowboat, because we don't have permanent collections, only 40 boats could do the same service. So it would be much cheaper for the city itself. The other use case that we're doing with the city is for passengers, right? And here you can see some of the sensors that we're using. Here is where we have the latching that you'll see soon. And basically, the latching, when two boats come together, it grabs, one boat grabs the other and stay connected without, so use electricity only to activate the latching, grab, and then you release. You don't need to use energy anymore. And this is important, not only for boat itself, but I remember we're not ready to do this at that point. It was around 3 years ago when the US Marines approached us. When we launched the first latching, it was not like that. It was more complex. This one would be better. But they approached us because of the following. When they deployed troops, one of the most critical parts of this deployment is when the vessels approach land. And then someone needs to go out and put the pontoon so the troops can come. So if we could latch and deploy this and one latch to the other, then it would be less risky to the troop. And also, if we see the configuration of the boats that I showed before, one thing that we are working a lot now is with what we call the multi-vessel coordination. Basically, it's the following. So let's say that we have this formation here with these chairs, but then I want to have all these chairs around the room. So what we say, okay, look, all chairs, you need to do this shape now. So the chairs with a distributed intelligence would say, okay, who goes first? So I don't need to say, you go first, then you move here. So the chairs itself would say, okay, so if I'm at that position, and this is the shape that I want, I need X chairs. So it's easier that these chairs come here, and so on and so forth. And this is also important for them when it comes, for instance, when we have oil spills, so you don't need to bring anybody there. You have this fleet, and all of them, we call them minions, so they come together. They are kind of the minions. Then you release the minions. They go do whatever they need to do. And then they reconvene, and then they navigate with only one of them taking control because they are latched. So it becomes kind of a tugboat temporarily, then it brings back, right? But so far, the boat is beautiful, etc., but it's not navigating. Then 2 weeks ago, we did this.
This is Lucy. Lucy is a rowboat, a fully autonomous, zero-emission boat that operates on urban waterways, and she can change the way cities work. As congestion and emissions continue to rise, while cities continue to grow, the existing infrastructure of many cities struggles.
Oops, Jesus, at this point. Let's start again.
This is Lucy. Lucy is a rowboat, a fully autonomous, zero-emission boat that operates on urban waterways, and she can change the way cities work. As congestion and emissions continue to rise, while cities continue to grow, the existing infrastructure of many cities struggles to keep up. Rowboats offer a solution by moving road traffic to the water. By bringing passengers from A to B, or as an on-demand boat, taking you anywhere you want. And they can also help the city as a multi-purpose workboat. Take Crystal. She is equipped to collect household waste to free the streets from heavy garbage trucks. Rowboats are fully autonomous, so they navigate without a skipper and can operate 24/7. In order to sail by themselves, rowboats need to perceive their environment and recognize objects such as bridge pillars, floating objects, and of course other vessels. The primary source of information comes from a LiDAR sensor, but rowboats are also equipped with cameras, GPS, and a digital compass. Rowboat's onboard computer combines and processes all of the data and runs the rowboat software so it can successfully complete its mission plan. After 5 years of development, testing, and experimentation, we have now successfully enabled autonomy on the full-scale prototypes. Rowboat is ready for the next step. Join us and let's unlock the potential of urban waterways together.
And then the boat, they also have a water quality sensing. So the city of Amsterdam, they are trying to make all the canals swimmable in a few years. Currently, they have some parts that you can go and swim, and they have the swimming day. But sometimes they have algae bloom, right? So how to detect that? They have some fixed sensors, and they rely on the fixed sensors and the water models. With the rowboat, if we could have a good enough water quality sensor, we could monitor this in real life, so in real time. And we achieved, I think, a good result more or less 1 month ago, because we've been testing. MIT has a nanotechnology lab where we were cultivating different algae and testing there. And now, with a device that's more or less the size of this projector, we are getting the same results with the device on the boat as we're having with the MIT Nanotechnology Lab, obviously for a fraction of the price. So rowboat is not only the vessel itself, but also all these different parts that are embedded in the boat. Next steps. So now we are entering into phase one of them. One part of the team based in Amsterdam, they are developing different use cases called what we call a bring it to practice, to say, okay, how reliable it is, stress test, everything. So we can perhaps have a startup and sell the boat in its entirety. But what we're also doing is what we're calling so far powered by rowboat. So let's say if we want to monitor water quality, you don't need the vessel, you need the device. If you want to have the latching or the docking, because even if we have some very interesting projects with some autonomous ferries, etc., when it comes to I used to say that they are more kind of in autopilot than in autonomous mode, because when it comes to the last meter, someone needs to go there and pull the rope. I say, oh my God, it's so 14th century, right? So you have autonomy, and then a 14th century technology to, oh, now I'm getting. No, the trick is, okay, now be fully autonomous. So it comes to the latching. So I think the robot now is all these parts that we can power other boats to be autonomous. So if you have any questions now, but if you have any questions later, please write me. I'm happy to answer. Thank you. Please. Thank you.
Yes, have you thought about like safety issues for people transportation? For example, detection of man overboard, that kind of thing. You know.
Yeah. So currently the project is still in a prototyping phase, and now we are working with the city of Amsterdam about all the safety issues. But one thing that we did was quite interesting, is when we were using with the virtual reality, we put people, 2 groups of people. One of them, the 2 environments would have exactly the same path with the same boat, and when you leave the docking stations, the first thing that would happen would be a boat coming towards you. The only difference was that on one side, when you entered the virtual boat, you could see a captain. On the other side, there was no captain. And then we were measuring stress level. So what's interesting is that, okay, and it was a 4-minute ride. So the first 40 seconds, when you don't have a captain, the stress level would spike. And then slowly it would decrease and stabilize. So we could not see the difference if the passenger was on an autonomous or a non-autonomous boat. But we think that we're going to have more issues, like say the boarding would be the critical. Once the person is on board, then we prove, okay, that's fine. But the boarding part, we know that is problematic. Thank you. Oh, we have.
I have a question about sensing.
Sorry.
I have a question about sensing, because we did a similar thing in Belgium,
Yeah.
but then they noticed that the boat had no one on board, and someone jumped in the canal and tried to board it, and we had the remote guy try to overtake. So did you guys have other stuff to sense it with, maybe underwater? Because at the end when the guy jumped in the water, we only saw the head, and it was dangerous for us.
We thought of electrifying the boat. Use someone touch and give a shock. No, I think, no, it's a very good point. But as I mentioned, so we're in this prototyping phase. And in this environment, we're not in the video, because then we were navigating the canals, but in our test site, during the summer, is one of the public swimming pools. So we are constantly negotiating with swimmers, but we're gonna probably know. We know that I think it's more than 100 people fall into the canals every year, and drunk people fall in the canals in Amsterdam every year. So probably we're gonna have this type of problems.
Good morning. Very good project.
Thank you.
Congrats. My question is more related to the navigation part of it. Is it waypoint based, or the AI on board decides the path from A to B?
Okay. So I can explain as much as I will explain as much as I can, because I'm not the specialist here. But we divide this in 2 parts. One is the global path planning. So okay, I want to go from point A to point B. Then before it starts navigation, the boat decides which is the best route, including other the traffic, the previous traffic that it has encountered there. But then at every time, if we have an obstacle, then the boat itself makes the decision based on DVL, basically, and LiDAR data, the distance. I don't know if I answered completely, but otherwise, if you write me an email, I can send to the, okay, thank you.
For the latching system, that's really interesting. Are you guys thinking about maybe, I don't know, like having an industry standard for those kind of latching systems? Because one of the reasons everyone uses a rope is because you can tie it anywhere.
Yeah,
So.
yeah. No, that's a good point, because initially what we'd like to do to Amsterdam, they have stairs in several points of the city. And then I said, oh, if we could find a way of grabbing the stairs, the ladder that goes from the street to the water, it would be much easier, and then we could have it anywhere. Then for us, it came the other problem, because the ladders, they are pretty narrow, and then if the boat is higher, we would need to have more attaching points. So that's why we came to this not ideal solution that we need to have a docking station to dock in this case, right? Luckily, in Amsterdam's case, they have several docking platforms distributed in the city, basically following the same standard. So we can include our latching, which is also a box like that. Almost is the negative of the latching, right? So you put it there. But we are working nice standard. But unfortunately, our idea, which was to have the latching only on the boat and grab whatever infrastructure is there, is not possible because of the size of the boat.
So sorry, just back on the navigation, does it work in a GPS denied environment? Or?
Oh, yeah. So it does have a GPS. We do rely on GPS when we go. There is the main river in Amsterdam called I. So when we go to the I, or we go to the connection between when the canals enter the I, so we have a larger, then we can rely on GPS. But when we enter the canal system itself, then we cannot rely on GPS anymore, because then we lose signal frequently. So that's why we are heavily relying. So they do have a very good 5G network already there installed, but then for the navigation, this more local navigation then needs to be LiDAR and processed on board. Oh yes, please go ahead.
Any thoughts on extending this to, like larger seafaring ships, like container ships and so on? Especially like what happened in Panama last year when a ship went sideways and got stuck.
Oh, yeah.
So any idea on how to extend this?
Yeah. So we think that our realm is more urban waters, because we do have several very good companies working on open waters, including here in Boston, including here at MIT. So our main goal is urban waters, with some solutions that can be used by companies that are already working on the open water problem. The first city that approached us was Tokyo, actually, for the opening of the Olympics. But then at this point it was too soon. We did not have the technology to do that. So thank you very much. If you have any questions, please feel free to write me. Thank you.